Hi there, welcome to Scholar Sauce. I'm Alan Perry, and today we're going to be checking out some AskMath Reddit questions. The first thread on AskMath that we're going to look at is this question about this meme here, which poses a probability question. It says, you hit an enemy twice, at least one of the hits is a critical. Assuming a 50% critical chance, what's the probability that both hits are crits? What this is getting at is a conditional kind of probability problem. It says that given that you hit an enemy twice, and at least one of those hits is a critical hit, then what's the probability that both are critical hits? And it gives us sort of a base probability of 50% chance of critical hit. That means that it is just as likely to not critical hit as it is to critical hit. So you can kind of set this up in two different ways. A really basic one is there are only two possibilities for each hit. Either you critted or you didn't crit. Given the four possibilities that could happen if you hit an enemy twice, either two critical hits, critical hit in the first one and a non-critical hit in the second one, or a non-critical hit on the first one and a critical hit on the second one, and then finally neither of them being a critical hit. There are four possibilities there, and they're all equally likely because hitting it with a critical hit or not is equally likely as well. However, this also says that at least one of the hits is a critical hit. So we know that in this scenario, the only possibilities are the three equally likely possibilities, and so given that there are three equally likely outcomes, we look at how many of them have both critical hits. There's only one of them, and so the answer ends up being 1/3. Doing this more formulaically, let's suppose that we have an event A and an event B. Event A is going to be that we critical hitted twice. And event B is that at least one of our hits was a critical hit. Then what this question is asking is what's the probability that we critical hit twice given that we critical hitted at least once? Critical hitted? Hitted? Is it hitted? Critical hit at least once? Yeah. That we critical hit once? That we criticaled at least once? I don't know. What's the probability that we critical hit twice given that we critical hit at least once? That's probably right. Well, formulaically, the probability that event A occurs, given that event B already occurred, is equal to the probability that both A and B occur, divided by the probability that B occurs. Well, the probability that they both happen, two critical hits and at least one critical hit, is the same as just two critical hits occurring. So the probability that two critical hits occur, like we said in that list of things we had, is 1/4. And that's going to be divided by the probability that at least one critical hit occurs, which, looking at our list again of the different outcomes, is 3/4 of the time at least one critical hit occurs. So therefore, the probability that two critical hits occur, given that one critical hit occurred, is going to be 1/4 divided by 3/4, which reduces to 1/3. In this particular meme, there was some questions about this. A few people described it sort of the same way I did. The best one is, but what if one of the hits is a critical and was made on a Tuesday by an unladen African swallow, which is pretty great. I love that reference to Monty Python. It's pretty funny. Anyway, the 1/3 is the correct answer. The guy who poses the question says, I saw this on Twitter and my conclusion is that it is ambiguous, either 25% or 50%. Definitely not 1/3 though. If it's implemented as an if statement, that is, if the first attack misses, the second guarantees a critical, it's 25%. If it's predetermined, that is, one of the attacks, first or second, is guaranteed to crit before the encounter starts, then it's 50%, since it's just the probability of the other roll. I'm curious if people here agree with me or if I've gone terribly wrong. And I think actually he's pretty close here. The part here that he has an issue with is that if it's predetermined, that is one of the attacks, first or second, is guaranteed to critical before the encounter starts, and he says then it's just 50% since that's the probability of the other roll. This is actually where he goes wrong, because there are two possibilities where one of them could critical hit and the other one doesn't, and they're both equally likely. That's two equally likely possibilities where only one critical hit occurred. And then you have a third equally likely outcome, which is where both of them critical hit. That's why it ends up being 1/3, because it's one out of three equally likely outcomes. Okay, let's move on to the next one here. This AskMath question asks us a little bit about how to solve a particular homework problem that a student's given. This is kind of fun because they're being asked to make some kind of construction, geometric construction. And so it says, hi, I was helping a kid with their homework, and they have these exercises where they're given conditions and they need to make a shape with said conditions. Most of it is pretty simple, except a certain one I seem to have a tough time figuring out. You're not allowed to calculate, only use geometry. Can anyone help resolve this? So here are the conditions. Triangle ABC, where AB is 10 centimeters. Angle BCA, which has to be 85 degrees. And then the median issued from B has to be 8 centimeters. That's all the information they're given. And they're struggling because they've asked other people, they can't figure it out. And maybe they haven't done geometry in too long. But here's the issue first, is to be really clear about what they mean by geometry. What I think this is probably talking about is they need to do it with a sort of compass and straight edge kind of calculation. Best place to mess around with this is GeoGebra. Okay, so in order to cook this up, I'm going to draw a basic generic shape here. So here's a triangle, sort of A, B, and then get a point C over here. This isn't going to be the correct triangle that we're talking about, but just so you can kind of see what we're talking about. We are going to find a midpoint of the side opposite B. And what we're trying to get at is that we want a triangle. We want to cook up a triangle that looks essentially like this, where this side length here is 10 centimeters. This side length here is 8 centimeters. These side lengths from C to D and D to A are congruent. And this angle here at C is 85 degrees. After thinking about this for a little while, you might be tempted to start with the 85-degree angle and try to construct from there. But I actually think the best place to start constructing is this point D here, the center of where the median will drop. So this is how I'm going to do that. So let's clear everything here. We're going to start here with that midpoint there. I'm going to relabel this one to be the point M. We're going to create a circle with a specific radius. So here we go. We've got circle, center, and radius. So we'll get an 8 centimeter radius here, which is something that looks like this. See that? So here's our point M. This is going to be where that median drops to. Somewhere on this edge of the circle is going to be where the point B is, because this is going to be 8 centimeters away. So I'm just going to pick a random point on that circle. We're going to label this one B, because this is going to be the B in the triangle. And notice I just picked a random point. I don't really care initially because I'm going to set up something where I can move this point along. But notice that I can move this point. It will stay on that circle. And that's going to be the important thing, is I want a point that's exactly a distance 8 away from M. In fact, I'm going to draw the line segment from B to M, the line segment BM. How smooth. Yeah, you probably didn't laugh at that, but I guess you have to either be a doctor or sitting on a stool to get that crappy joke. Yeah, I don't even know if I should include that one. Whew. Yeah, I guess you could say that joke stinks. Oh, gosh. Okay, so let's actually take a measurement. This should be 8 because that's what we created it as. So what we're going to do now is we want to find a point A that's going to work. I'm going to cook up a line that M is going to be on. This is going to be the line that I'm going to place both A and C on. And then what I'm going to do is we now need to create the side AB of this triangle. And that's got to be a distance 10 away from B. So I'm going to take another circle with a specific size, circle here, and I'm going to say I want one now with a radius of 10. Okay, and what I'm going to take is I'm going to take the point where that guy intersects the other side there. And that's actually what I'm going to call the point A. And you can see that if I click there and measure that distance, that's going to be a measure of a distance 10. And also this is kind of cool because now no matter where I move B, that computed point will always be exactly the 10 away from B. So M will always be, BM will always be 8. And BA will always be 10. But notice as I move it along, it forces where that calculated point A is. I can even go around the other side of the circle. You can kind of see that the furthest away it can get is 18 from M. The closest it can get is 2 from M, because that'd be 10 minus 8. But the answer is going to be somewhere in between here. All right, so let's just set it up there for a minute. Now, I know that M is supposed to be the midpoint of the other side. I know that that means that the length M to the point C has to be the same length as the length M to the point A, which means that if I cook up a circle centered at M again, but goes out to point A, then I'm guaranteed that this other point here is always going to be exactly the right distance away. So I'm going to put a point here, and that's actually going to end up being the point C. That'll be the other point of the triangle. Okay, so let's actually cook up the rest of our triangle. Now, this will be what we want. It has almost all the properties that we want to have. So first off, it has that the median length is 8. The side length opposite the angle we're interested in is 10. You can see that no matter where we move it, and we're going to maintain that relationship, that the median is 8 and the length between B and A is 10. What I'm going to do is I'm going to measure this angle here. I'm going to take this tool here. We're going to measure the angle from A, C, B. And you can see right now, I'm going to drag that out a little bit more so we can see it. That's 64.4 degrees. But if I move this B, it's going to increase that. And all I need to do is increase that now to 85 degrees. Let's see if I can nail it or get really close to it. You can see that it's going to, oh, there we go, 85 degrees. So at that point, you have precisely the triangle that they're looking at to do. It has an angle BCA that's 85 degrees. It has a length of AB that's 10 centimeters, a length of B that's 8 centimeters. The sort of tricky part is that you had to kind of create these things in a way that you could float that angle at the end. There is a GeoGebra one here that he messes with that doesn't. It does look like it's pretty close to an isosceles triangle. Apparently, it's not exactly. It's close. The next one here actually has an interesting point. He says that if you use the law of cosines, you can actually cook up two equations that are required, which will actually give you the value of the sizes that you want to do. But they weren't allowed to do any calculations beforehand. Okay, let's take a look at another one. The next one here is this proof of the Pythagorean theorem that doesn't bite its own tail? What he means by that is this a proof of the Pythagorean theorem that doesn't use circular logic, that doesn't like assume the Pythagorean theorem is part of it? And actually, this is a pretty good one. It's pretty classic. To construct this one is pretty straightforward. You want to start with a right triangle. You have sort of an A and a B all the way around, and then a side length C in the middle. If you take the area of the whole thing here, which will be A plus B quantity squared, that's the area of the entire big square, and then subtract off from it 4 of the areas of the triangle that's here, because those are the same triangle copied 4 times, then you should get the area of the inside, which will be the area of this square here, that's C squared. And indeed, if you do that, the result of that equation is Pythagorean's theorem. And yeah, so his question is that accurate? A good proof that doesn't bite its own tail? And it is. It's actually a pretty classic proof that's well known. What's really cool about the Pythagorean theorem, there's like 300 different proofs of the Pythagorean theorem or more. In fact, some that have just been recently discovered that use trigonometry. Trigonometric proof was thought to be impossible because of this exact issue of having some kind of circular logic. A lot of trigonometry is based off of the Pythagorean theorem. If you're going to use a trigonometric idea in order to prove the Pythagorean theorem, you'd have to avoid using trigonometric ideas that are based on the Pythagorean theorem. And that was thought to be impossible for a long time until just recently. But yeah, this is absolutely a great proof that the person has. It turns out apparently this kid was in the hospital and was bored, was just doing math on the side just for fun, because that's, I mean, what else would you do if you were really bored? In fact, if you're interested in curious Pythagorean theorem proofs, I actually have a pretty fun video that hasn't gotten a lot of views because, I don't know, thumbnails and whatnot. But it's about how President James A. Garfield came up with an original proof of the Pythagorean theorem that nobody had apparently published before. And so, he got to, some mathematicians that talked to him about it asked if they could publish it, and they did. And if you want to watch that video, you can click on wherever the tag is up here that allows you to click on it to watch that video. It's a really fun one. I hope you guys really enjoy it. By the way, if you're just joining us now, please hit that subscribe button. About 90% of my viewers aren't subscribed, and it would be awesome if I could get more. Let's check out another one. So this one here is about logic. This is kind of an interesting one. So here we got 2 statements, A and B. Which of the following statements by A and B implies one or more of the other statements? And so here you have that statement. A says either A is true or B is true. B is A implies B. Now, in the way that they're using this, the word implies here, when you have 2 statements of this form, simply is the statement that not A or B. That's what that implies symbol is indicating. I actually think personally that's a terrible way to use the word implies, but nonetheless, in this video, in this particular thing, that's what the A implies B is referring to, is not A or B. Similarly, B implies A will be not B or A, and then the D and E, not A implies B, is not A or B. So A or B. The bottom one is not B or A, which again is B or A. So both D and E are actually saying the same thing. And so A is saying either A is true or B is true. So that's A or B. Whether you think of it as the exclusive or, which sometimes the either or is referred to as, or if you think of it as the inclusive or, both D and E follow from the claim of A. By the way, this jives with sort of what everybody else is saying down here. You can even see this one here. P implies Q is equivalent to not P or Q, which is fine. And that he comes to the same conclusion that they're all equivalent as well. If you do say that A means the exclusive or, meaning that either A is true or B is true, but not both, then you'd only have that A implies D and E. D or E would not imply A, because D and E are both the inclusive ors. Anyway, let's move on. Let's do the last little bit here. Let's just have a little bit fun here. This one was pretty interesting. This is from a math memes one rather than AskMath. It says, I legit did this in a math test and now I can't stop laughing. What he did here basically is he foiled or used the perfect square trinomial formula, which is, again, foiling, where you square the first term, double the product of the 2 terms that are there, and then add the square of the 3rd term. And it turns out that it works, and this is actually just fine. But if he just used the order of operations, he could have just taken the 2 and 3 together and gotten a 5 squared, which would give him 25, which would have been much faster. But it was interesting. One of the reason why I thought this was kind of cool was if you go down and you look at some of the comments, this one here, sometimes this isn't even the long way. If you want to know 55 squared, it's the easy way to calculate 50 plus 5 squared equals 2,500 plus 2 times 250 plus 25. And in fact, you can do this even with other numbers, like this one here. You can do this with other numbers too. 67 times 73 equals 70 minus 3 times 70 plus 3, which is actually a difference of squares. You get 4,900 minus 9 equals 4,891. And so a lot of these properties end up being pretty nice to make mental math a lot quicker. And really, people who are really quick at mental math are doing tricks like this all the time. Let's take a look at something funny. What's the best math joke that you know? What does the B in Benoit B. Mandelbrot stand for? Benoit B. Mandelbrot. Now, this is funny because the Mandelbrot is famous for the Mandelbrot set, which is a fractal. And what the quality of a fractal is that the fractals look the same no matter how much you zoom in on them. And so you can kind of see in this Mandelbrot set animation that no matter how much you zoom into the Mandelbrot set, you continue to see Mandelbrot sets over and over again. And so the B in Benoit B. Mandelbrot stands for Benoit B. Mandelbrot. And then there's another B in there, which also stands for Benoit B. Mandelbrot. And so no matter how much you zoom in to Benoit B. Mandelbrot's name, you find another Benoit B. Mandelbrot. That's why it's funny. And this is a great comment. That guy was so full of himself. That is peak. I love it. That's really awesome. Oh, this is awesome. Of all the primes, 2 is the oddest. The reason why this is funny is because 2 is the only even prime number. All the other primes are odd because all other even numbers are divisible by 2. And so 2 is the weirdest prime number, being that it's the only one that has the property of being even, which means it's odd, which, hopefully you can get the joke from there. But yeah, 2 is definitely the oddest prime number, even if it's the only non-odd prime number. Let's see here. This one's actually one of my favorite ones. I have a YouTube video that has me telling this joke here. Physicist, a biologist, a mathematician are sitting in a street cafe, watching people enter and leave the house on the other side of the street. First, they see 2 people entering the house. Some time passes, and after a while, they notice 3 people leaving the house together. The physicist says, the measurement we had wasn't accurate. The biologist says, nah, the people must have reproduced. But the mathematician says, hey, if one more person enters that house, it'll be empty again. And the reason why is because if you assume that the house was empty initially and 2 people went inside, then you now have 2 people in the house. So the population of the house is 2. Well, if 3 people leave, then the population of the house is 2 minus 3, which is now -1, which would require another person to enter the house for the population to be 0 or empty again. That's the joke. That's pretty much it for today, guys. I hope you enjoyed hanging out with me on some subreddits. If you enjoyed this video, please give it a like and subscribe to Scholar Sauce. I'll also put a couple of fun videos up here that you can check out if you like it. Particularly if you liked this kind of content, please let me know in the comments and maybe I'll make a few more of these. Anyway, have a great day and I'll see you next time on Scholar Sauce.